The AI coding revolution, how open models are challenging GPT 5.5 and Claude. What if the most powerful AI models in the world were no longer controlled by just a few companies? What if businesses could access advanced AI systems at a fraction of the current cost, customize them, and even run them privately? This is no longer just a theoretical idea. A major shift is happening in the artificial intelligence industry. Two new open-weight AI models from China, Kimi K2.7 code and GLM 5.2, are entering the competition with a clear message. High-performance AI is becoming cheaper, more accessible, and less dependent on a small number of companies. At the same time, major moves involving AI coding platforms and next-generation voice technology are showing that the AI race is expanding far beyond just building bigger models. Let's start with Kimi K2.7 code. Developed by Moonshot AI, Kimi K2.7 code is not designed as a general chatbot for everyday conversations. Its main purpose is software development. The model is built for what the industry calls AI coding agents. Instead of simply answering programming questions, an AI coding agent can understand an entire software project, analyze code, find problems, modify files, test solutions, and continue working through multiple steps. This changes the role of AI. It is no longer just a tool that gives suggestions. It becomes a digital programming partner. Under the hood, Kimi K2.7 code is a massive AI system. It uses a mixture of experts architecture, meaning the entire model does not need to activate all of its computing power for every task. Only the necessary parts of the model are used at each moment. This approach helps improve efficiency and reduce operating costs. The model reportedly contains around 1 trillion total parameters, while only a smaller portion is active during each task. For businesses, this difference matters. Running powerful AI models is expensive. A system that can deliver strong performance while using fewer resources can make AI agents much more practical. Another important improvement is reasoning efficiency. Previous AI systems sometimes spend too much time thinking before producing an answer. For coding agents, that can create unnecessary delays and higher costs. Kimi K2.7 code focuses on reducing this overhead while maintaining strong problem-solving ability. In real-world testing environments, the model performs well on tasks that simulate actual developer workflows. These include interacting with code repositories, databases, browser automation tools, and other software systems. While GPT 5.5 remains extremely competitive on many advanced evaluations, Kimi K2.7 code has shown that open models can now compete seriously with premium closed systems. One example is MCP Mark Verified, a benchmark designed to evaluate AI agents in 2U scenarios. Kimi K2.7 code has achieved results that put it ahead of some leading models in this category. The important point is not simply that one model beats another. The bigger story is that the gap between open and closed AI models is becoming smaller. And then there is the biggest advantage of all: price. For companies using AI agents every day, cost is a critical factor. AI agents do not make just one request. They perform many actions, test different solutions, and repeat tasks until they reach a result. This can create huge expenses. Lower-cost models could allow companies to run more AI agents without dramatically increasing their budgets. But Kimi K2.7 code is only one part of this new wave. Another major player is z.ai with GLM 5.2. GLM 5.2 takes a different approach. Instead of focusing only on short programming tasks, it is designed for long and complex engineering workflows. The model supports a very large context window, allowing it to process huge amounts of information. This includes documentation, source code, previous changes, and detailed project instructions. For developers, this ability is extremely valuable. A real software project is not just a few lines of code. It can contain thousands or even millions of lines, along with years of accumulated information. The challenge is making this large amount of context useful without making AI too expensive. Z.ai has introduced technical improvements designed to reduce the computing cost of processing very large contexts. This allows GLM 5.2 to handle longer tasks more efficiently. GLM 5.2 is becoming one of the most interesting examples of how quickly open AI models are improving. On software engineering benchmarks, the model has achieved impressive results and is now competing with some of the strongest proprietary AI systems. One important evaluation is SWE Bench Pro. Unlike simple coding tests, SWE Bench Pro measures whether an AI can solve real software engineering problems. The AI must understand an existing code base, identify the cause of a problem, make the necessary changes, and produce a complete solution. This is much closer to the type of work professional developers do every day. GLM 5.2 has shown strong performance on these types of tasks, even reaching results that compare closely with advanced closed models. However, the real story is not simply about one model defeating another. The bigger change is that open-weight models are becoming good enough to challenge systems that were previously considered far ahead. For years, the best AI models were available only through expensive APIs controlled by a small number of companies. Now, businesses have more options. They can choose between premium closed models and increasingly powerful open alternatives. And this competition could push the entire AI industry forward. Beyond performance, there is another important advantage of open models: control. With open-weight AI systems, companies can download the model, customize it for their own needs, fine-tune it with private data, and run it on their own infrastructure. This is especially important for companies dealing with sensitive information. Instead of sending everything to an external AI provider, they can maintain more control over their own technology. This also reduces the risk of depending entirely on a single provider. As AI becomes a critical part of business operations, flexibility and independence will become increasingly valuable. But the AI race is not only about models. It is also about the tools people use every day. And this leads to another major story: Cursor. Cursor has quickly become one of the most popular AI-powered coding platforms in the world. Unlike a traditional chatbot, Cursor works directly inside the developer's environment. It understands the project structure, analyzes files, suggests improvements, and helps developers build software much faster. The rise of Cursor shows an important shift. The future of programming may not simply depend on who creates the smartest AI model. It may depend on who creates the best experience around those models. There have been reports suggesting that SpaceX could be interested in a potential deal involving Enisphere, the company behind Cursor. While details remain unconfirmed, the interest itself shows how valuable AI coding platforms have become. Why would a company like SpaceX care about a coding assistant? The answer is simple: productivity and data. Every time developers use tools like Cursor, they create valuable information about how software is designed, debugged, and improved. This real-world developer behavior could become extremely useful for training future AI coding systems. The competition is no longer only about building larger AI models. It is about creating an entire ecosystem. The model, the infrastructure, the tools, and the user experience. Finally, another major area of AI development is voice. OpenAI is reportedly working on the next generation of AI voice technology, with the goal of making conversations with AI feel much more natural. Today, AI voice assistants are already impressive. They can generate realistic speech and answer questions quickly. But there are still limitations. Conversations can feel unnatural. Interruptions are sometimes difficult. And there is still a noticeable gap between speaking with a machine and speaking with another person. Future voice models could change this by allowing AI to listen and respond more naturally at the same time. The goal is not simply better pronunciation. The goal is creating a real conversational experience. If AI becomes a daily assistant for billions of people, voice could become one of the most important ways humans interact with technology. A powerful AI that is difficult to communicate with will always have limitations. But an AI that feels natural to talk with could completely change how we use computers. Looking at the bigger picture, one trend is becoming clear. The AI industry is entering a new phase. Open models are becoming more powerful. The cost of advanced AI is decreasing. Coding agents are becoming more capable. And the relationship between humans and AI is becoming more interactive. The next AI battle will not only be about who creates the smartest model. It will be about who can make artificial intelligence the most useful, accessible, and integrated into everyday life.